So we are now going to try to frame an equation to depict the performance of a computer. So which obviously we call the performance equation. So a compiler generates machine language program corresponding to source program. This is what we've been seeing since the start of this chapter. Your code is converted into a bunch of machine language instructions. So let us assume this particular code I have written has been converted into n instructions. So the number of instructions I need to execute are n. Now we have a computer which is capable of executing s instructions in one clock cycle. So let's say the total number of instructions is 100 and my computer is capable of executing 20 instructions in one clock cycle. Then my n here is 100, s here is 20. So obviously we need 5 clock cycles to be able to complete the entire program execution. And r, as we saw, is the clock rate in cycles per second. So the total time required would be n into s divided by r. Here n refers to the number of instructions, s is the number of instructions that can be executed per clock cycle, and r is, as we saw, the clock rate, number of cycles per second. So if you check the dimensions of this quantity, it would be instructions into instructions per cycle divided by cycles per second. So the final quantity will be of units, seconds or milliseconds, microseconds, whatever. So ultimately our performance equation is this: time taken is n into s divided by r, where n is the total instructions that my machine language code has for whatever program I wrote. S is the number of instructions my system is capable of executing in one clock cycle, and r is the clock rate, that is the number of cycles per second, that is the inverse of the cycle length of the system. So this is the performance equation. So when you want to compare the performance of two systems, what you do is you take a program, you convert it to machine language, you figure out how many instructions are there, and then the hardware architecture will tell you how many instructions can be executed per cycle and what the clock rate is. So using these quantities, you will calculate T1 and T2 for the computers 1 and 2 respectively, and then you will compare them, and whichever takes less time is going to be the more efficient or the faster computer. That's how we measure performance.